Okay, so we have another example here where they're talking about a situation, and we're going to draw it out. It says there's a straight road leading from the town of Westboro to Agratown, 30 miles east to 10 miles north. Okay, now that sentence to me was a little confusing, but here you have Westboro, so I'll put a W for Westboro, and Agratown is 30 miles east and 10 miles north. So that's Agratown, okay? So 30 miles, 10 miles. Okay, and so there's this road that runs between the two towns. Okay. Let's see, I thought I was going to say something else, but anyway. You could think of this as an ordered pair up here as 30, 10. And you can think of Westboro as being 0, 0. So you could think about like a coordinate system, your X and Y, going something like that. That will be helpful. Okay. Now, it says part way down this road, it junctions with a second road, perpendicular to the first. Okay, so there's another road. I gotta try to draw it perpendicular. Okay, something like that, where that's like a right angle there, okay? And then we have this second road. And let's see, it leads to the town of Eastboro. So this is Eastboro. It doesn't really say which direction Eastboro is, but we'll draw it this way. Okay. Let's see, perpendicular to the first, leading to the town of Eastboro. If the town of Eastboro is located 20 miles directly east, okay, so that means, boy, this distance here is 20, okay? So I have an ordered pair for Eastboro. This point right here, this point right there, is going to be 20, 0, okay? All right, so that's our situation, kind of a messy little diagram. Okay, if the town of Eastboro is located 20 miles directly east of Westboro, how far is the road junction from Westboro? So we're trying to find this point right here. I don't think I drew my perpendicular line very perpendicular. Should be more like, well, I'm just going to mess up my diagram, but okay. There we go. So we're trying to find that point. Well, what we need is, we need a model for that equation. We don't have enough information. Well, we have enough information to find the slope of that line, right? Okay. But we don't know where it intersects. That's the thing. Okay. So let's look at, let's see, the line from Westboro, I'll call it line 1, from Westboro to Agratown. Okay. So we know that the slope for line 1 is going to be, let's see, 10 minus 0 over 30 minus 0, or that's going to simplify to be 1/3. Okay, so that's just point slope, right? Okay, or the slope formula. And we're using the 0.00 and the 0.310. So we know the slope of the road from Westboro to Agratown. Okay, great. And then we know the intercept is 0. So we could actually say the equation, let's see, the distance equation, I guess, from, or line 1, I'll just call it line 1, is the slope, 1/3. Yeah, I'll just use x. We'll just call this like the x and the y-axis like we're used to. And then plus 0 because it's going through, the intercept is at the origin. Okay, so line 1, the equation of that is 1/3 x. Okay, now we know that line 2, I'm going to write this in here somewhere, line 2. So from east to the Eastboro to the junction, that's going to be line 2. Well, line 2 is perpendicular to line 1. So the slope of line 2 is going to be -3, right? So opposite reciprocal. Okay, so that's the slope of that line. And And we know an ordered pair for that line. So I can use point slope formula. So y equals, I was meant to write the point slope formula. Y minus y1 equals slope times x minus x1. Okay, and what's the point I know for that line, that perpendicular line, line 2? I know the point 20, 0. So I can say y minus 20, or I'm sorry, y minus 0 equals negative 3 times x minus 20. Now this is all for line 2. This is what line 2 is going to be. Y equals negative 3x plus 60. Okay? And we want to know when those are going to be meeting, right? So when does line 1 equal line 2? All right. So when does 1/3 x equal negative 3x plus 60? That would be where the junction is. This would be the junction, right? Okay, so when the two lines are equal to each other. All right. So let's see. Let's multiply through by 3 to get rid of the fraction. And let's go ahead and add the 9x over. So that's going to give me 10x equals 180. And so x equals 18. Okay, so I know the coordinates for this point. I know the x value is 18. And then what's the y value going to be? Well, you could go to either equation, this equation or this equation, line 1 or line 2. It's probably easier to use line 1. So we can say line 1 is going to equal 1/3 of 18. And that's the y value that's equaling that. I put line 1. I probably should put y, but anyway, it's going to be 6. So that's the ordered pair, 18, 6. Okay. Now, what does it want to know? How far is the road junction? We want to know this distance right here. The distance between 0, 0 and this point now that I've found, 18, 6. So let me write that out, more room. What's the distance between, you have to remember my diagram, 0, 0 and 18, 6. We're going to use a distance formula. The distance formula equals the square root of x2 minus x1 squared plus y2 minus y1 squared. But the one point is 0, 0, so that helps. So you're just going to have like 18 minus 0 squared plus 6 minus 0 squared. And that's going to be, I have to find more room to write, the square root of 18 squared plus 6 squared. Ooh, what's 18 squared? Let's see. Don't remember that one. 18 squared. 324 plus 36. I'll add the 36. And then I want to take the square root of that. Okay. I got 360 when I added those together, I hope. And it looks like I get approximately 18.9736. Keeps going. So it's about 19 miles. Okay, that was a long problem. We had to use a lot of different things. We had to use the idea of perpendicular lines. We had to draw it out and get the diagram, find the point where they meet. And then we had to use a distance formula to find out the distance. But it looks like it's, how far is the road? About 19 miles.